So with our exponential growth and decay, we can look at writing equations to represent how much money I might have, or how much something is worth, how many of something is still left after so much amount of time. So in the last session that you had in class, we talked about a formula that was very similar to this one, except it was y equals a times 1 plus r to the t. And this would represent a growth model, where a is the starting amount and r is the percentage that we grow by. And we add that to the 1 so that we're talking about 100% of what we have plus whatever our rate is, and then we raise it to the t power, which represents our time. You can use the x variable too, and that's fine. So, some real life examples of exponential growth might be population, the net worth of something, your debt on your credit card, and so on. Exponential decay, again, could be net worth or population if we're looking at an endangered species. It could be bacteria treated with medicine, and so on. So there's lots of ways in which we can see exponential growth and decay depending on whether the thing that you're looking at is increasing or decreasing. So let's look at an example. Ian buys a brand new Escalade. He pays $50,000 for the car in crisp minted $1,000 bills. Every year, the value of the car decreases by 8%. So we're going to write a model to represent the value of this car. We're going to call it y after t years. So the value of the car, okay, we started at paying $50,000, and it decreases by 8%. So I have 100%, and I'm going to minus, and I'm going to write 8% as a decimal. Okay, so now using your calculator, we can determine how much the car is worth after 5 years. The t variable is already in years, so we don't have to convert anything. So I'm going to type into my calculator 5,000 times 1 minus 0.08, or you could say 0.92, raised to the 5th power. And I get, so my 50,000, again, I can rewrite that if you wanted to, is 50,000 times 0.92 to the 5th power. So I'm going to do 50 times 0.92 raised to the 5th power. I get $32,954, and I have 0.07616. They never round up with pennies, so it's going to be in 7 cents. Okay, so how much then is the car worth in 20 years? All right, let's look at bank accounts. So whatever amount, so if I go to the bank and I want to open a savings account, I have an initial principal, which means that's the amount of money I deposit initially into my account. And depending on the account that you get, it's going to pay interest at an annual rate, and that's our R. And it's compounded n times per year. That means at this many times per year, it is going to look at how much money you have and then give you your however much percentage back into your account. Okay, so that's this equation right here. Okay, so n is your number of times compounded, r is your rate, t is your time in years, and p is your principal amount. So if I deposit $4,000, that's my principal, into an account that pays 3.5%, so that's 0.035. Find the balance after 1 year if it's compounded with, and in this case, quarterly. That's every 3 months. That means 4 times a year. So I'm going to have 1 plus 0.035 over 4 raised to the 4t. That's my equation. So now you can plug in 1 for your t, and get out your answer. So when I did that in my calculator, I got $4,141 and 84 cents. Again, we don't round up. Okay, now if I do that weekly, I need to know how many weeks are in a year. There's 52, so my end value is 52. So again, I'm going to use my equation. I start with the 4,000. And I'm going to plug in 1. So I will have $4,142.43. So that one would be slightly better to have. And then I want you to try the other one.